What's going on here? You stupid machine. All right, so maybe it's not going to let me open this. That's fine. Not a big deal. We'll do it the old-fashioned way. Okay? So I'll do this, approach this as I would have as a high schooler when I didn't have a graphing calculator. But you could certainly just type these into the graphing calculator and look at the picture. And I'll sketch a picture after I do it the by hand way, just so you can kind of see-ish what I would be talking about, although you won't see the individual directions on how to graph something on your calculator. But that should be something you're relatively familiar with, since you would have done it last year a lot. Is that okay? All right. So we're going to look at these same three functions that we just looked at. So I'm going to abbreviate relevant domain just as RD. And we're going to use that. So, what I care about really three things here in determining the range. I care about, is there a lower bound to this function? Like, is there a smallest y value it can have? Is it continuously increasing or continuously decreasing? And then, is there an upper bound? Is there a biggest y value it can have? Everybody's okay with that idea? Okay. So what do we know about what the graph of a square root function looks like? You graphed these last year, so you should kind of remember that either this or like something like that. Right? Where it has a definitive starting point. Well, I guess it could go the other direction too, right? But it'll look like one of these things. Everybody's okay with that? That there's a definitive start or end to it, but then it either increases or decreases forever afterwards. Everybody's okay there? Okay. So I can tell by looking at the leading coefficient if it's increasing or decreasing. What am I looking for in the leading coefficient? Just if it's positive or negative, right? If this is positive, I'm going to have it multiplying to another positive. And if I multiply positive to positive, I'm always going to get positive. And I know that as the number under the square root gets bigger, the square root of that number is going to get bigger also, right? Like if 2 is bigger than 3, if 3 is bigger than 2, the square root of 3 should be bigger than the square root of 2, right? Everybody's okay with that? That should be very commonsensical. So I know that this thing is increasing all the way. So we're looking at this one. Everybody's okay with that? So my range is going to start at f and then go to positive infinity. And because this is included, I know there's an x-coordinate that has the value 4. I know there has to be a y-coordinate at f of 4, right? Is everybody okay with that reasoning? So all I'm left to do is really compute what f of 4 is, which in this case is just 0. Okay. Okay, our relevant domain was Now this is the trick wise, because rational functions do not behave very nicely. Remember trying to graph these things last year? They kind of did all kinds of crazy stuff on us, right? So there are a couple of rules, though, that helped me. Number one, I should be able to tell if I have some kind of horizontal end behavior going on just by looking at this function. Since I have nothing added or subtracted from the end of it, I know the horizontal end behavior I can predict by looking at the degree of the polynomial in the numerator and denominator. Since I have a degree 1 polynomial over another degree 1 polynomial, that horizontal end behavior is just going to be the leading coefficient of the numerator over the leading coefficient of the denominator. So if I was to think about the graph of this, I'd have some kind of horizontal end behavior here at y equals 3. Now I say end behavior rather than asymptote because just by looking at the function, I can't tell if I'm going to have something like, well, I know there's an asymptote here at, have something that happens like this, or I could have something that happens like this, where it's going to cross that line and then drop back down to it. This is kind of our nightmare scenario, right? Because we can't really do much with this without calculus in order to do this. So I'm really going to default. I'm just going to open another piece of graphing software because the calculator, the stupid emulator isn't opening for me, even though I've clicked it like 150 times by now. Just to let you know, by the time I'm going to have like 50 windows of the stupid calculator open. It just, for whatever reason, isn't working for me right now. Which is pretty irritating, but that's the way it goes sometimes, right? So what I'm opening right now is Graphmatica. I showed you guys, or I talked about this briefly our first day of class. Again, this is a free download. You don't have to download it, but it's pretty nice. So I'm just going to type in the function real quick here and hit enter. And then I'm going to zoom out a little bit so I can get a better picture of what's going on. But this is pretty good for me. So I can tell just by looking at this now what the range is going to be because of what I ascertained before about that horizontal end behavior. So I can look at this and see that y equals 3 sure as heck looks like an asymptote, right? I see no evidence of it jumping up and then coming back down to 3 or, you know, falling under and then coming back to 3. It looks like it's just going to be following 3. Do you guys agree with that? Okay. So what that's basically telling me then is I have all the negative y coordinates up to 3, right? And if I look at this arm of the graph, I have all the positive y coordinates after 3. Everybody agree with that? Yes? So what's that tell me my range is then? This is what my graph looked like. Actually, I think it was the reverse, right? Doesn't really matter. It's like this. So my range is just that, which is what I was hoping it was going to be, but you can't tell just by looking at the function because these rational functions, weird stuff can happen. And then our last one is the easiest one, I think, because we basically identified this. Anybody take a guess as to what the range is going to be? Remember, all we're doing is cubing the, all we're doing is cubing s, right? Check, right? If I think about this, if I graphed y equals x cubed, the graph looks basically like this, right? Do you agree with that? But we've just capping it here, right? I guess we have the open circle there, right? That's what our graph is going to look like because we've just cut off all the negative part to it. So what are the y values here? Just all the positive numbers. Same as the x's. Is that okay? Okay, so we did this kind of commonsensical, right? And looking at some graphs. Let's do this like strictly algebraically also, just to kind of give you a different idea of what you can do here. Okay? And I mean, when I say algebraic, I mean like symbolic algebra. We're going to basically do the same procedure we would do to find the inverse. So if I wanted to find the inverse for this function, what would I do first? So the first thing we want to do is get x by itself, and then we swap x and y, right? That's to find an inverse. Step that we're going to worry about, though, that's going to help us find the range, is just getting the x by itself part. So to do that, the first step would be to divide by 2, right? Then what? You've got to square both sides to get rid of the square root. When you square a fraction, you have to square the numerator and square the denominator. Is okay there? Then if we add 4 to both sides, we get this, right? Everybody agree with this? I want to go all the way to here. Oh, I'm dumb. We made a mistake here. What's the mistake? It's subtle. It's very, very subtle. It's actually very hard to see what the mistake is. So mistake is going from this. Yeah, so there is an issue here. We expanded something we shouldn't have. Remember that our domain is only 4 to positive infinity. if we squared both sides, the domain would then all of a sudden become all real numbers, right? Everybody's okay with that? Let's just look y real quick. So this was bad. We didn't want to do this. Here, we have a square root. So we know that we can't plug in any values for x because some of them will give us negatives. For example, if I plugged in 1 for x, I'd have -3 and it'd be bad, right? But I can here. I can plug in 1 for x and it's no problem. So we didn't want to do that. What's the minimum value this can have? If I square root something, what's the smallest number I can get if I take the square root? Zero, right? Everybody agree? It's the biggest number I can have if I take the square root of it. There's our range again, right? I don't love doing these this way, but you can. I find it's typically easier for me to do it kind of a little bit with the calculator and a little bit with common sense. But if you prefer symbolically, like this will work. But you got to be a little bit careful. Notice that on this one where we tried just bulldozing along, we ran into some issue. We don't run into that same issue here. So what I'm going to do is try to get the x by itself. This is actually tricky to do. So I'm going to start by cross multiplying. Standard method that we learned to solve a ratio like that. And then we'll distribute the y through. And I'm going to subtract the xy from both sides to get the x's on the same side. And then I'm going to factor an x out because I have a greatest common factor of x on that right-hand side. And then divide both sides by the 3 minus y to get the x by itself. So if I look at this expression, what values of y can't I have? Just 3, right? Because it would give me a 0 denominator. So that is the same thing that we saw before. Y cannot equal 3, which is the same thing as what we wrote for the range before. So that's easy to do for these rational ones. I mean, the algebra is a little bit tricky on how to get the x by itself. But they're all kind of like that. Once you've figured out how to do it for one, it's pretty easy to do it for all of them. But the doing this is maybe not the first thing you would have thought of. You know, to cross multiply and then get all the x's on one side and factor an x out and divide by everything else. You know, if you haven't done that in a minute, maybe is not the most obvious algebra to do. But once you've done it once or twice, it's like, oh yeah, just do that same procedure again. And with the volumes, because it's pretty straightforward there. So we'll stop here. That's probably good for today. We have, I don't know, like 7 minutes or something left of class, but it's not really enough time for me to want to get into the next idea. And you guys have been quite supportive and participatory, so I'm happy with what you guys have done there. I want to point out to you guys real quick, though, on Power School, I started posting some of these assignments. So remember, the assignments are due into your OneNote notebook at midnight on Sunday. If the world's slowest internet wants to cooperate for me. You probably have seen these things starting to populate right on PowerSchool if you've been on there. Oh, my network connection.